Welcome to part 2, Sum, Difference, Double Angle Identities. We're going to start with the sum and difference identities. So, is this like when we have polynomials, when we have x times a plus b? Is that the same as xa plus xb? Well, let's see if it works for trig identities as well. Does cos 30 plus 60 equal cos 30 plus cos 60? So, 30 plus 60 is 90. So, cos of 90 equals cos of 30 plus cos of 60. Okay, cos of 90 is equal to 0. Cos of 30 is equal to root 3 over 2, and cos of 60 is 1/2. I hate to break it to you, but 0 does not equal root 3 over 2. Oh, totally messed that up. Try that again. Root 3 over 2 plus 1/2. So, I don't think that identity works. So, but there's a pattern that does work, and you can see them here listed. Sum and difference identities are recognized by the patterns produced. So sine of a plus b is equal to sine a cos b plus sine b cos a. So if you recognize the pattern, it's a sine cos and a cos sine, okay? Or vice versa. And again, a plus b, it's sine cos plus sine cos, okay? Sine a minus b, same pattern, but the subtraction sign is between them. Cos is a little bit of a different animal. If you notice, it's cos a cos b minus sine a sine b. So, first of all, it's cos cos and sine sine, so the pattern's different. And if you notice, it's a plus in the middle of the left side, but a minus in the middle of the right side. So it does switch it up a bit. And tan has got its own thing going on there. So tan a plus b, tan a plus b, tan b, minus or over 1 minus tan a times tan b. So it has 1 plus and 1 minus. So the same sign goes on top as what's given on the left side. Again, no worries about memorizing this. You find it all on your formula sheet. Again, what the key here is recognition of the pattern. Okay, let's try some examples. Write each expression as a single trigonometric ratio. So if you notice, it's sine cos plus sine cos. And the angles switch. So it's 23 and 22, and then 22 and 23. So which of the 6 up here have that pattern? Well, it looks to me like it's the same as the first one. So in this case, then, A is going to equal 23, and B is going to equal 22. So this is the same thing, then, as sine of A plus B, which is sine of 23 plus 22, which is the same as sine of 45 degrees. Okay, awesome. Let's look at part B. Cos angle, sine angle, and we're subtracting. So again, take a look at your list. Which one has that pattern? Cos, sine, sine means that it has to be a cosine. Which one is it? It's the one with the subtraction in it. So we look, and that's the same as cos of A plus B. In this case, A is pi over 4, and B is 3 pi over 4. So, cos of A plus B is equal to cos of pi over 4 plus 3 pi over 4, which is the same thing as cos of pi. Okay, because 1 pi and 3 pi make 4 pi over 4s, which is just pi. Awesome. Tan 95 minus tan 35, 1 plus tan 95, tan 35 on the denominator. Okay, let's take a look up top. And that looks to be the very last sum and difference identity. So that is A is going to equal 95, and B is going to equal 35. So that means that tan of A minus B equals tan of 95, take away 35, which is tan of 60 degrees. Okay, good stuff. On to the next page. This is great, right? All right. Determine the exact value for sine of 15 degrees. Okay, now, 15 degrees is not a measure that's on our unit circle. So how do we find its exact value? Well, the cool thing is we can use one of the sum and difference identities from the previous page. So we have a couple here for sine we can use, A plus B or A minus B. Now, if you recall, on our unit circle, the special angles were 0, 30, 45, 60, and 90. Is it possible to find two things that either add or subtract to 15 from that list? Well, sure, we've got a couple of options. We can use 30 and 45, or we can use 45 and 60. I'm going to go with 30 and 45. So, sine of 15 degrees is the same as sine of 45 take away 30. So, if we use the formula from the previous page, sine of A minus B, that equals sine A cos B minus sine B cos A. Subbing in for A and B, that becomes sine 45 cos 30 minus cos 45 sine 30. Remember, this multiplication, so order doesn't matter as long as they're both on the same side of the subtraction sign. Sine of 45 is root 2 over 2. Cos of 30 is root 3 over 2. Minus cos of 45 is also root 2 over 2. And sine of 30 is 1/2. Again, those values coming off your unit circle, so refer back to that if you have forgotten what they were. Okay, top times top, bottom times bottom. So, root 2 times root 3 is root 6 over 4. And root 2 times 1 is root 2 over 4. Okay, so that becomes root 6 minus root 2 all over 4. Okay, and that is the exact value, because I mentioned before, remember, exact values do not include decimals, so you have radicals and fractions. It's all perfect for exact values. All right. If you want to take out your calculator, make sure it's in degree mode. Type in sine of 15. Press enter. Then type in bracket root 6 minus root 2 and bracket all over 4. Guess what? I bet you get the same thing. Perfect. Okay, let's try cos of 7 pi over 2. So, or 7 pi over 12, sorry. Again, there's no pi over 12s on our unit circle. Is it possible that it could be a combination of some other things? Well, 7 pi over 12, I can make that 3 pi over 12 plus 4 pi over 12. If we simplify 3 pi over 12, because they're both divisible by 3, okay, that becomes pi over 4. And 4 pi over 12 are both divisible by 4, so that becomes pi over 3. All right, those ones are on our unit circle. So we have cos of 7 pi over 12 is the same thing as cos of pi over 4 plus pi over 3. Now, looking back on the previous page, cos of A plus B is equal to cos A cos B minus sine A sine B. So let's use that formula there. Cos of pi over 4 plus pi over 3 equals cos pi over 4 times cos pi over 3 minus sine pi over 4 times sine of pi over 3. All right. Cos of pi over 4 is root 2 over 2. Cos of pi over 3 is 1/2 minus sine of pi over 4 is root 2 over 2, and sine of pi over 3 is root 3 over 2. Okay, let's simplify. That becomes root 2 over 4 minus root 6 over 4, or root 2 minus root 6 all over 4, because they have the same denominator. Whew, that was fun. All right, I'm going to just add another page here because I do not have a room for tan of 165. So just hold on a sec. Add a page. There we go. Okay, tan. There we go. Tan of 165 degrees. Okay, how am I going to get that to work? Well, again, we have special angles. 0 and 30 and 60 and 45 and 90 and 120, 135, 150, 180. Can we use some combination of those guys to get 165? Well, I'm thinking of 120 and 45. Those look like a good combination. Added together, those make 165. So this is the same thing then as tan of 45 plus 120. Okay, so going back a couple pages to look at our tangent identities. Okay, we have tan of A plus B, so we're going to use this guy, is tan A plus tan B over 1 minus tan A tan B. Okay, try and remember that for a couple pages here. Okay, so we have tan of A plus B equals tan A plus tan B over 1 minus tan A times tan B. Subbing in, so we have tan of 45 plus 120 equals tan of 45 plus tan of 120. Got a little excited there. Okay, over 1 minus tan of 45 times tan of 120. Okay, tan of 45 from our unit circle is 1 plus tan of 120. 120 is in quadrant 2, so I know that's a negative. And it's a multiple of 60, so therefore tan is root 3. Okay? Good. On the bottom, 1 minus tan of 45 is 1. Tan of 120, again, is negative root 3. All right. So let's simplify. So we get 1 minus root 3 on the top over 1 plus root 3 on the bottom. Yuck. We have a binomial radical on the bottom. So to simplify it, we have to multiply by its conjugate, which is 1 minus root 3. But if I multiply the bottom by that, I must keep things equivalent, so I'm going to multiply the top by that. Because technically this whole thing, that is something divided by itself, which equals 1. So I'm not changing the value, I'm just changing how it looks. Okay, multiplying that up, I would get 1 times 1 is 1, minus root 3, minus another root 3, that's minus 2 root 3's. Negative root 3 times negative root 3 is positive 3. All over. Something times itself is just a difference of, a binomial times its conjugate is the difference of squares. So first guy squared minus the second guy squared. Okay, on top, that gives me 4 minus 2 root 3's when I collect like terms, all over negative 2. So when I simplify that out, negative 2 goes into 4, 2 times. And negative 2 goes into negative 2 root 3, positive root 3 times, or you can write that as root 3 take away 2. Good, and again, you can always check this by typing in tan of 165, make sure you're in degree mode, and then when you're done that, press root 3 minus 2, and you should get the exact same decimal number. Good, again, notice it's an exact value because it contains a root sign and not a whole bunch of decimals. All right, number 3, as if you weren't having enough fun. Sine of pi over 2 minus theta equals cos theta. We're going to prove that. Okay, so again, as soon as you see this going on, you know that that is a sum and difference identity. So sine theta, pi over 2 minus theta, so that is equal to sine of pi over 2 cos of theta minus cos of pi over 2 sine of theta. And we're going to show that it equals cos theta. Okay, sine of pi over 2 is the same thing as 1 times cos theta. We don't know what that is. Cos of pi over 2 is equal to 0, and that's times sine theta. Okay. And so 1 times cos theta is cos theta, and 0 times sine theta is 0, so cos theta take away 0 is cos theta. And we just proved that it works. Okay, that was a much faster example. All right, number 4. I love these questions, but most kids don't like them so much. Okay, given sine of A is equal to 5 over 6, and cos of B is 5 over 13, A and B are acute angles. So what that means is that they are less than 90 degrees, which means if we're talking unit circle, they'd be in quadrant 1, which of course again means that x and y are both positive. we're going to determine the exact value of cos of A minus B. Okay, so cos of A minus B is the same as cos A cos B plus sine A sine B. Okay, I know sine A, so I can sub in for that. And I know cos B, I can sub in for that. But I don't know cos A, and I don't know sine B. So how am I going to find them? Well, I'm going to use right triangles. So here is one right triangle. And sine, of course, if this is angle A, sine is equal to opposite over hypotenuse. So 5 over 6. How do I find the x value for A? I'm going to use Pythagorean theorem. So x is equal to the square root of 6 squared take away 5 squared. So that's 36 take away 25, so that should give me square root 11. Okay, good. Let's take a look at the other triangle, cos of B. So this guy looks like that. So XA is root 11. All right, so cos B, remember if this is angle B, then cos is adj, which is 5, over hyp, which is 13. So how do I find y of B? Well, y of B is going to equal the square root of 13 squared take away 5 squared. So that's going to equal 12. 13 squared, 169. 5 squared is 25. Subtract them, you get 144, which is a perfect square, the square root of which is 12. Okay, now cos A should then equal x of A divided by the hypotenuse. So that's going to equal root 11 over 6. Cos of B is given, so that's 5 over 13. Plus, sine of A is also given, that's 5 over 6. And sine of B is YB, which is 12, over the hypotenuse 13. So that's side opposite over 13. Good, now we can multiply, so that's 5 root 11 over 78 plus 60 over 78. Okay, and then that simplifies to 5 root 11 plus 60 all over 78. Okay, awesome. And that is the answer to that question. On to the next part. Okay, we'll skip by that page because we already looked at it. Okay, if you want to pause and take a break here, I know this video is going to be a little lengthy for you, so by all means feel free to stop here. If not, then let's carry on with double angle identities. Double angle identities are named due to the 2 in front of the angle. For example, sine 2a, the 2 doubles angle A. Investigate how to get the double angle identities. So, if 2a means to double the A, it's the same thing as A plus A. So, I can use my sum and difference identities with sine of A plus A. Remember that it's equal to sine A cos A plus, and again, sine A cos A. Oh, well those are like terms. How many of them do I have? I got 2. So that's equal to 2 sine A cos A. So sine of 2a is equivalent to 2 sine A cos A. Great. What about cos of 2a? Well, again, it's cos A plus A. So using our sum and difference identities, that's cos A times cos A minus sine A times sine A. Well, cos A times itself is the same as cos squared A, and sine A times itself is the same as sine squared A. So there's one identity right there. Now, we can also work in the Pythagorean identity. Remember that sine squared A plus cos squared A equals 1. So then sine squared A is equal to 1 minus cos squared A. So in place of sine squared A, I'm going to substitute that in. So that becomes cos squared A minus 1 minus cos squared A. Remember to substitute it in brackets. So cos squared A minus 1 minus becomes plus. So that becomes 2 cos squared A minus 1. I can do the same thing by substituting in for cos squared A. Cos squared A would equal 1 minus sine squared A from the Pythagorean identity. So if we substitute that in, we get 1 minus sine squared A minus sine squared A. So that becomes 1 minus, I have subtracting 2 sine squared A's, so that I can write this way. So there you got your double angle identities. And there again, all of these are found on your formula sheet, so please don't memorize them, just make sure that you recognize them. Okay, write the following as single identities. So 2 sine pi over 3 cos pi over 3. That really looks like this identity, so that's the same thing as sine of 2 times, my angle is pi over 3, so that is sine of 2 pi over 3. Okay? Next one, 2 cos squared 7 minus 1. That looks like this guy, so that's the same as cos of 2 times 7, or cos of 14. Okay? And the last one, well, it's got tan in it, so it should look like this guy, but it doesn't have a 2 tan on top. Oh, wait a minute. Tan 25 plus tan 25, that's the same thing as 2 tan 25s. A little tricky there. Okay, and the bottom looks right, 1 minus tan 25 squared. Good, so in this case, our theta is equal to 25. Okay, so that would mean that this is the same as tan of 2 times 25, or tan of 50. And again, you are more than welcome to check all of these things just by typing them into your calculator and seeing that you get the same answer in both cases. Okay, great. Whew, one more page. Prove the following identities. Sine squared theta is equal to 1 minus cos 2 theta all over 2. Okay, I know that sine squared theta is the same thing as 1 minus cos squared theta using the Pythagorean identity. I also know that cos 2 theta has a number of ways to be written, but if I'm looking for coses, I probably don't want to use the first one, I'm going to use the second one. So 1 minus bracket 2 cos squared theta minus 1 all over 2. Okay, good. Now, I can simplify the top by collecting some like terms. So 1 minus minus becomes 1 plus, so that becomes 2 minus 2 cos squared theta all over 2. Notice that they both have 2's in them, so I can divide them all in both terms in the numerator by 2. So 2 goes into 2 once, and 2 goes into 2 cos squared theta times, and now left side equals right side, and the proof is complete. Part B. Cos theta plus sine theta all squared equals 1 plus sine 2 theta. Alright, I am going to expand by multiplying that binomial. So that becomes cos squared theta plus 2 cos theta sine theta plus sine squared theta equals 1 plus, and again, sine 2 theta is the same as 2 sine theta cos theta, using a double angle identity. Alright, now here I have cos squared plus sine squared, because remember this whole side is addition, so you can rearrange to everything that's being added, and so that gives us cos squared plus sine squared. I know that's the same as 1. Plus, I can rearrange this because this is multiplication, so again, order doesn't matter, so I can rewrite that as 2 sine theta cos theta, and guess what? It's the same as the other side. And another identity has been proven. Part C. Cos 2 theta is equal to 1 minus tan squared theta over secant squared theta. Okay, so cos 2 theta, I'm going to use cos squared theta minus sine squared theta. And again, if this one doesn't work, we're just going to erase it and try something else. Okay? Equals. Now, I'm going to separate these into 1 over secant squared theta minus tan squared theta over secant squared theta. Okay? Because remember they're both being divided by secant squared theta, so I can separate them as individual terms. Now, again, the right-hand side looks a little more complicated, so I'm going to work with that. 1 over secant squared theta means to take the reciprocal, but the secant is the reciprocal of cosine, so taking the reciprocal of the reciprocal gets us to cos squared theta. Minus tan is the same as sine squared theta over cos squared theta. And again, dividing by secant is the same thing as, multiplying by 1 over, or by cos, over cos squared theta over 1. Because again, secant is the reciprocal of cosine. If you'll notice, the cosines cancel, and I'm left with cos squared theta minus sine squared theta, which happens to look like the stuff on the left side. Okay, last example, and then you're free to try some of these on your own. Find the exact values without using a calculator of sine 2 theta and cos 2 theta if tan theta is equal to negative 3/4 and theta is a quadrant 4 angle. What that tells us then is in quadrant 4, x is positive and y is negative. So we can use that information to help us figure out sine and cosine. Okay, so tan theta is equal to y over x is equal to 3 over 4. And again, we know that y is negative in quadrant 4. This helps us to find the radius, because in order to find sine and cos, we need to know r. So again, that's equal to the square root of 4 squared plus negative 3 squared. So that's going to give us a radius of 5. Okay, so then sine theta is equal to y over r, which then would be negative 3/5, and cos theta is equal to x over r, which is equal to 4/5. Okay, so sine of 2 theta is equal to 2 sine theta cos theta, so it's equal to 2 sine of theta is negative 3/5, and cos of theta is 4/5. So 2 times 3 is 6, times 4 is 24, and that's a negative. And 5 times 5 is 25. So sine of 2 theta is equal to negative 24/25. Cos of 2 theta, doesn't matter which one we use, we'll go with cos squared theta minus sine squared theta, because I have both of those. So cosine is 4/5 all squared, minus sine, which is negative 3/5 all squared. 4/5 squared is equal to 16/25, minus negative 3 squared is positive 9/25. 16 take away 9, because they have the same denominator, is 7/25. All right, hope you enjoyed this long and interesting and really awesome video, and you can now practice on your own starting on page 306 of your textbook. Don't forget to show your teacher.